In this video, section 3.2, inversing multiplication. What we want to start here is with a nice multiplicative equation. Say something like 7x is equal to 35. Now what we need is some number x such that when I multiply it by 35, or excuse me, when I multiply it by 7, we get 35. Similar to what we did with section 3.1, we're just going to go ahead and look at some operations here, look at some products with 7. 7, 14, 21, 28, 35. Ah, that's what we wanted. 35. That's the fifth operation there. So 7 times 5 is equal to 35, which means that x is equal to 5. Great. We found a solution. We've got a way to get the solution, but we're still just guessing. We want a process. So, let's think about this. 7, 5, 35. How are they related? Well, 7, excuse me, not 7, 35 divided by 7 is 5. And let's take a look at, again, the left-hand side of this. What happens when I take 7x and I divide by 7? Well, we can reorder this multiplication. This is all just multiplication here. And say, hey, I'm going to take 7, divide it by 7 first. I'm left with 1. So this is equal to x. So we take 7x is equal to 35. I'm going to divide both sides by 7. Got to do it to both sides. Now, 7 divided by 7 is 1. The left-hand side reduces to x. 35 divided by 7 is 5. We've got our solution. And just like we had previously here, this division by 7, it's the inverse. This is the same concept of what we were doing as in section 3.1, but now we've got multiplication instead of addition. So we use the inverse and divide by 7, divide by 7. We applied it to both sides. And again, that's the golden rule of algebra. What you do onto one side, you have to do onto the other. Okay. Let's take a look at another problem. Let's say we start with 9x equal to 72. I want to think about the inverse of 9 here. 9 times 1 over 9 is equal to 1. So I can either multiply both sides by 1/9 or divide both sides by 9. So that's the operation I'm going to perform. Now I'm going to fill in the rest of my equation around it. 9 divided by 9 is 1. Left-hand side reduces to x. 72 divided by 9 is 8. And that's what my right-hand side reduces to. And again, what we're doing is we're using the inverse operation on both sides. Okay. Let's switch it up a little bit. Let's take a look at an equation that's structured a little bit differently. What I'm thinking of is something like this. If I take x, I divide it by 3, and I set that equal to 11. How are we going to solve this? Well, we want to take a look at 3 and think 3 times, or excuse me, that's not 3, that's 1/3. So this whole thing, what's multiplying x is 1/3. We're dividing by 3. The inverse of that is to multiply by 3. So I'm going to take both sides of the equation and multiply by 3. Okay, now these are going to cancel out. The left-hand side will reduce to x. The right-hand side, 11 times 3, 33. We've got our solution. In the next one, I want to look at something even more different. I want to take 4, divide it by 7, then multiply it by x, and we're going to set that equal to 24. Well, we're going to do this one in 2 parts. First, we're going to look at 4, and we're going to say 4 times 1/4, that's 1. So I'm going to take this side, multiply by 1/4, or divide by 4. But since we have a fraction right here, it looks a little neater if we use multiplication by the reciprocal. And we'll fill in the rest of the problem about it. Okay, these 4's will cancel out. We'll be left with 1/7 times x is equal to 6. And I'm also going to just rewrite 24 times 1/4 over here. Now, 1/7. 1/7 times 7, that's equal to 1. So I'm going to take this side, multiply it by 7. Take the right-hand side, multiply it by 7 as well. Golden rule. We must do this to both sides. And like I've been doing, we're going to write the rest of the equation in around it. These cancel. They leave us with 1. So the left-hand side simplifies down to x. And then this right-hand side becomes 42. Alright, what about this over here? Let's finish filling this out. We're going to have 24 times 1/4 times 7. I want to take these and group them together. That's 7/4. Yeah. 4/7, 7/4. They're reciprocals. So instead of doing 2 operations here, we multiplied by 1/4, then we multiplied by 7, then we got the answer, we could have instead just taken, 4/7 x is equal to 24, multiplied both sides by 7/4, and gotten our answer. This still would have been as hard to simplify just by using the reciprocal. And knowing about inverses. Let's take a look at one more example. I want to do a improper fraction, if you will. Again, a mixed fraction, whatever you want to call it. I want to take 5/2 x, set it equal to 35. Okay. So, what we need to think about here is 5/2. What's the reciprocal of it? It's denominator as numerator, numerator as denominator, 2/5. Now if I take 2/5, I multiply it by 5/2, I get 1. So I'm going to take 2/5, multiply both sides of the equation by it, Then we'll fill in the rest of the equation around it. And these both cancel out. We're left with just x on our left-hand side. And then we'll have 35 times 1/5 is 7. 7 times 2 is 14. Do a little bit of scratch work there. X is equal to 14. That's our solution. And similar to what we did in section 3.1, we can write this as a theorem. When we have something of the form ax is equal to b, then the solution will have the form x is equal to b divided by a. And this is theorem 3.2.1 in the textbook. That's all for inversing multiplication. Thank you.